This video, we're going to use completing the square to write the equation of a parabola in vertex form and then identify its vertex. These are all instructor created questions. You won't find these exact problems or anything quite like them in your textbook, but this is one of our core objectives of class. And it's really going to get you ready for some things that you're going to do in pre-calculus. You're going to use completing the square a lot, not just for parabolas, but for other types of equations that have perfect squares involved in them, like circles and ellipses and hyperbolas and things like that when you get into the second half of pre-calculus, should you take that. But in the first part of pre-calculus, you're going to use this with parabolas. So everybody needs to know this for this part, getting these in vertex form. So let's start off with y equals x squared minus 8x plus 18. Let's take just a second to discuss what the square is that we're completing. That if I have a plus b squared, that equals a squared plus 2ab plus b squared. If I have a minus b squared, it equals to a squared minus 2ab plus b squared. So I'm going to, just for a second, even though we normally write a before b, I'm going to switch these middle terms around to say that it's 2b times a, like that. And I know that I always have a plus b squared on the end there, and I'm going to keep the sign in my factor here of what this middle term is, but the coefficient that's here, ignoring the sign, is 2b. So if I take half of the middle number and square it, I get the number that I need on the end. I want this a squared part to always be x squared, which it is here, or my variable squared. I don't want any coefficient in front of it. We'll learn how to deal with that in a little bit, just a couple problems away. So I'm going to look at this part, x squared minus 8x, separate from the plus 18. And I'm going to take half of this coefficient here. Half of negative 8 is negative 4. Negative 4 squared is negative 4 times negative 4 is a positive 16. And I can't go into the problem here adding 16 without balancing it out by subtracting 16 as well. 16 minus 16 was 0, so I really did nothing to the right-hand side other than change the way that it looks. So this is going to be an x minus 4 quantity squared. 18 minus 16 is a plus 2. Now my vertex form of my parabola looks like this. A times the quantity x minus h squared plus k, where my vertex is at hk. So if I would set the parentheses equal to 0 and solve, my h would be 4. When h is 4, all this is 0. 0 plus 2 is 2. So my vertex is at 4, 2. Don't worry if you didn't catch all that the first time through. We're going to go ahead and do a couple more examples like that. All right. Y equals x squared minus 12x plus 38. I'm getting ahead of myself here. I want y equals x squared minus 12x. Half of negative 12 is negative 6. Negative 6 squared is 36. So I'm going to get y equals x minus 6 squared plus 2, and my vertex is going to be at 6, 2. Now we're going to have a little bit harder problem because the leading coefficient isn't going to be 1 this time. It's going to be 5. Y equals 5x squared minus 40x plus 88. So the first thing I need to do is with this part that's got the x's in it, I need to factor the 5 out. I'll leave that 88 alone over there. Half of negative 8 is negative 4. Negative 4 squared is 16. Now I just added 5 times 16, so I need to subtract 5 times 16. So 5 times x minus 4 squared plus 88 minus, and then this is going to be 90. It's going to be y equals 5 times x minus 4 squared minus 2. And so my vertex is going to be, don't worry about this 5. It doesn't have anything to do with the vertex. It's going to be at 4, negative 2. 5 has to do with how much the graph is stretched out. And whether the graph opens up or down. Okay. We have y equals 3x squared minus 42x plus 150. So y equals 3 times x squared minus 14x plus 150. Half of negative 14 is negative 7. Negative 7 squared is positive 49. And I need to subtract 3 times 49. That's 147. And y equals 3 times x minus 7 squared plus 3. And my vertex is going to be at 7, 3. All right. That's going to be it for these problems. We're going to come back next time and we are going to find the vertex of the parabola using the formula method instead of this completing the square method. Both methods work, but we need to know completing the square for other shapes. This formula method is only going to work to find the vertex of a parabola. So it's not going to work in those other situations that I was talking about where you're going to need to know completing the square for other techniques and for other types of shapes or other situations in pre-calculus and calculus. So that's not going away. All right, we'll come back and talk about the formula method next time.